What is condensation in thermodynamics? Have you ever noticed how water droplets form on a cold glass of lemonade on a hot day? That fascinating process is known as condensation, and it plays a vital role in thermodynamics. So, what exactly is condensation in this context? Let's break it down. Condensation occurs when a substance transitions from a vapor or gas state to a liquid state. This happens when the vapor loses energy, which can occur through a drop in temperature or an increase in pressure. As the gas molecules lose energy, they slow down and begin to come closer together, eventually forming liquid droplets. At the molecular level, this process is quite interesting. When gas molecules encounter a cooler surface, or when the surrounding air cools down, they lose kinetic energy. As they slow down, the attractive forces between them become strong enough to pull them together into a liquid. This is why you often see condensation on cold surfaces or when warm, moist air cools. In thermodynamic systems, condensation is a key component of many cycles and processes. For example, in the Rankine power cycle, commonly used in steam power plants, condensation is essential. It converts steam back into liquid water, allowing the cycle to continue efficiently. Similarly, refrigeration cycles depend on condensation to remove heat from a system. Here, refrigerant vapor turns into liquid, absorbing heat when it evaporates again. There are two primary modes of condensation, filmwise and dropwise. In filmwise condensation, vapor forms a continuous liquid film on a surface. In dropwise condensation, droplets from and fall off the surface. Each mode has different effects on heat transfer, which is important in engineering applications. Condensation is also a significant part of natural processes, such as the water cycle. Water vapor in the atmosphere condenses to form clouds and eventually leads to precipitation. Understanding condensation helps explain whether patterns and is fundamental for designing systems that manage heat and moisture effectively. In everyday life, you can see condensation when water droplets form on a cold glass or window, especially in humid conditions. It is also a consideration in building design, as condensation can lead to moisture buildup in walls, potentially causing issues like mold growth if not managed properly. Overall, condensation is a phase change driven by energy loss in vapor. It is essential for both natural processes and engineered thermodynamic cycles, making it a fundamental concept in understanding how heat and matter interact.